Hello everyone, welcome to the Tech Hench. Today we are going to solve another interesting Java problem. Uh, this problem is a bit difficult to understand, but it's quite simple to solve. So we'll look at the problem that we have at our hand today. This could be, a commonly asked question into your interviews. Not commonly asked, but in case of mid-level or high-level questions that would be asked in an interview. Okay, so let's jump to this problem. Anyways, this problem was asked in one of the SDET interviews as well. So let us understand the problem first, then we'll try to break the solution that how this is going to be solved, and then we'll be finally writing a code to see the code in execution. Okay, so let's just see what is the problem at hand. So you are given a record of historical prices of investment assets. Okay, so it's something like you would be given a record of some asset or maybe some share, you can say that, for and last 10 days, like say for example for last 10 days, 15 days, you would be given the price list of a share. You would have to analyze the record in order to calculate what could have been your maximum income. Okay, so this is a type of question that is quite common. This could be, change in terms of, you have limited money, in terms of you would have shares already, or you would have to buy that one in that sense. But let us see, this particular problem at her hand is quite simple right now. So let us see what are the given statements one by one. So it is like we have to analyze it for maximum income. That means we would have to trade over the last historical data to get the maximum profit out of it. Okay, assume you start with one asset of this type. So that means you have one asset already with you. That means one share you already have and could hold at most one at a time. You can have one share at time only. Okay, so this problem can be further changed, like, to make it more difficult. This could be like you can have multiple shares, you can have a limited amount of money that could be given. But for the problem at our hand today, what it is like, you have one asset at the time. That means whatever end days data would be given at the initial stage, you can consider that you had one asset of the type and could hold at most one asset. So means you can just hold or buy only one asset, you can sell it and you can again buy it to maximize your profit. Okay, so you could choose to sell the asset whenever you held one. Okay, if you did not hold an asset at some moment, you could always afford to buy an asset, assuming that you whatever the value of that asset is, you have infinite money, you can buy it. Say for example, the asset could be of 1 rupee, 2 rupee, 100 rupee, 1000 rupee, million rupee. Okay, but you can always have enough money to buy it. But only condition is that at the start you have one asset with you, and you can have at max one asset only with you. Okay, so it means we would have to, over the period of time, we would have to sell and buy that asset in order to maximize the profit. Okay, what is the maximum income you could make? Okay, write a function. The function would be something like int solution, where an integer of array would be given, and in n, let's see what a and n is. The given array a of length n representing, so it is just like size of array, and a is the array. We'll just pass the array itself. We can extract the size of array directly from here. But let us see what it returns the maximum income you could make. Okay, as a result, maybe large return its last 9 digit without leading zeros. Getting it? That means we would have to get the last 9 digits in case the size, or say, the amount or the profit is more than 9 digits. Okay, we'll handle that at last. But just let's focus on firstly to get the maximum profit. Okay, so examples are always important for to solve any given problem. Let us see and understand the example that we have at our end. It is like given array is like 4, 1, 2, 3. That means on day 1 the price was 4, on day 2 its price was 1, and day 3 price is 2, and day 4 price is 3. So it clearly says that the function should return 6. How? You can tell, you could sell the product on the first day, right? Say, I mean, it is condition, then assume you started with one asset. So we already had one asset. So what you would see, like, you could sell it for 4 rupees for first day, right? And buy it again on 1, right? I can sell it for 4 rupees, and then on day second I can buy for 1 rupee, then sell it again on the 3, because I won't sell it on 2, because on 3 I already know that, because this is historical data and I already know that on last day it is going to increase the price. So that means I will sell at 4. This will be my profit, 4 rupees. Then I would again buy it. Then that means I would have to spend 1 rupee. This is what it is saying, 4 plus 1 minus, and then at last I will sell it for free. That means I'll sell it for 3, then plus 3 would be, and addition would be 6. Okay, so this would be the answer. Similarly, another arrays are given, 1, 2, 3, 4, 5. So it is like, if I have to sell it, I'll see that I won't sell it on 1. I can sell it. I won't sell it on 2. I will sell it on 3, right? Once I'll sell it on 3, then what to say? You could sell the product when its value is 3, right? And buy it when it changed to 1. And when I will buy on the lowest, then on 1, and then I will again sell it on 5. uh, it is written wrong. It is to be sold on 5. Okay, so this way I would have to see you know the maximum return profit. This is the value more than 9 digits, so it is something like, function should return this, like maximum possible profit is 29999 something, and only the last 9 digits should be written. So whose last 9 digits are this should be written, and an effective algorithm will see that. Okay, we'll see this problem, we'll see the solution to this problem now. Okay, let's just now try to solve that problem in a graphical way. We'll see that which all decision user would have to make each day in order to maximize its profits, and we'll see that how we can make those decisions while writing a program for that problem. Okay, so say, I mean, as for problem, we are one investor, right, who already have one asset already with us at initial stage, right? Then you got some historical data of all days, all 4 days. I'm taking the example of same problem. It was 4, 1, 2, 3, right? So on day one, say for example, you have one asset. On day one, you see what you see. Since you have all days data with you, right? What you see is that your day one price is greater than what that of day two, right? Since you have, there are two things. Uh, I mean, there are two binary decisions that you would have to make. One is that if you have that asset already or not. By what that means is, like, do you have an asset to sell or not, right? And second is the current day price greater than or less than that of day two, right? So obviously, if you want to sell it, you will see that if your current day price is greater than that of next day, that means, so on day one price is 4, and I already know that on day two price will decrease. So obviously I would have to sell it on day one in order to avoid losses, right? So decision is like, do I have, is selling possible, right? So the binary says true, that selling is possible. And at the same time, day one's price is greater than day two. Okay, so what I will do, I will sell it immediately, right? The decision would be to sell it. So once I sell it, I won't have that asset, but this would add to my profit. What it would add? The price on day one, right? So profit is 4 right now. So now say we move to day two. Okay. Now the binary decision of selling something is false. Why? Because we don't have anything to sell. There was only one asset, and we can hold at max only one asset only. So we don't have anything to sell out, right? So next decision is to purchase, right? So what it says is like, I want to purchase, so I would look out for, you know, the decision would now be reversed. Say for example, I will look out for a day where price is low, right? So now on day two, I can see that on day three the price would increase. So what I will do, I will buy on lower prices, right? I won't wait for price to increase on two, because at two, or maybe I can, maybe on further days I can sell it on, definitely if I buy it today at one, definitely at least I can sell it on at price of two. Okay, so what would be the decision? Buy it, right? Since I know that on the day three price would, which is 2, would be greater than 1. So today is the price lower than next day. What I will do, I will buy now, right? So we'll buy this asset. So after buying this asset, to buy this asset, I would have to make loss of the price for today, which is 1. So the profit would be 4 minus 1, right? And I will have that asset now. So the selling binary now changed to possible because we have that asset to sell now. Now what we will see at day 3, we'll see that on day 3 we will see that boss on day 4 the price is going to increase. Uh, so this their decision is either we can sell it or we can hold it, right? Because buying is not possible, we cannot buy more than one. So either we can sell or hold, because we see that the price on final day is going to increase, which is 3 greater than 2. So what we will do, immediate decision would be to hold it, right? uh, we would we would hold this stock or share that we have with us, and we'll wait till day 4. On day 4, obviously it is the last day, so we would have to sell it. If so, so there comes another decision. Say, I mean, this would be specifically for day 3, right? If we have something to sell, I mean, on day 4, or that means the last day of any array. If we have something to sell, whatever the price it is, we will sell it. Why? Because holding won't give us any value, but if we sell it, this will generate us some value. So at this last day, whatever the price is, we are going to sell it, and this price is going to add up in our profit. So okay, so the final profit will become 6. So this would be the approach to solve this problem, that we would have two decisions to make uh, based on asset. I mean, do we have asset? Then selling is possible, right? This is one binary, and we'll look out that is current day price greater than that of second day. If it is greater, that means we will make profit today, and tomorrow we will make losses. We will sell it, and at this time selling is not possible. We can purchase it. Now the decision would be in the column that will the price increase. If the price increase, that means the price to buy that asset would increase tomorrow, so we will buy it today only. Okay, so let's just write a solution code to this. Okay, so let us now try to solve this problem and write a code for this. I'll create a new class for the same, and we'll solve the similar way we have just discussed. Okay, so I'll give the class a name as max profit, because we are trying to look out for maximum profit in this. Okay, let us write a main method first. Public static void main we should have, and it takes string array as our as parameter. And what we will do is we will write another uh, method in generic that would return us the max profit. Okay, static max profit, right? Max profit should be the name, and let us, okay, max profit, what it will do is static, no, we'll need a return type, say return type to integer. Okay, for now we have taken integer only, and we'll take a dummy return type. Okay, so what we'll do, it will receive array, whatever array we would have, array, say for example it will receive some integer array, right, in terms of prices, and we will return out of it, right? So let us take the array examples that we have first, no? So we'll take out the array examples that is here. I'll take this up in the array, right? And ARR or price array 1 equal to, so whatever the values are there, we'll have to change it to curly braces. Say this is our array. Okay, this is our problem array, integer okay, yeah, I did not give that symbol of array. Anyways, so this is the array that we will pass. Now what we will do is we will sys out the output of max profit. Okay, so this will return something in terms of max profit, and we have to send the array into it. Okay, so the max profit will be logged onto the as information, or we can write like max profit, right? This way, the better better display or better better logging of the message. Anyways, now we will have to write the logic to find the maximum profit out of it, right? So we'll traverse in the same way. We'll have to form few binary conditions in order to decide when we are going to sell, when we are going to buy. So I'll write two conditions, um, or maybe we can take one condition only, which is like selling applicable, because I mean at this condition we can hold only one, at max one variable only, oh sorry, at max one share we can hold, and we can sell, one we can hold. So at 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 a time you can either sell or you could either buy, right? Because when you don't have you can buy, when you have you can only sell, you can't buy more, right? So I'll take one boolean condition only, is selling applicable. Okay, that will be for very start it would be true. Why? Because it is given in a condition that you at the very beginning you have one asset to sell. Okay, so now I will what we'll do, we will traverse over the array of prices to compare the prices over different days. Okay, I will take an integer I equal to 0, will traverse over I less than equal to arr dot length minus 1, right? So we'd have to this has to be, we have to traverse till last index, and by that time we will have to increment this and integer I, right? Use wrong symbol. Now what we will do is I will take the price on the ith day, no, ith ith value, right? Ith value, what is the ith value? Will be ARR of I, right? Definitely. And now, since we discussed in the conditions, on all the days except the last days, we have to make, conditional decision. Do we have something to sell, and is it good to sell or not? Or do we have something to buy, or is it good to buy at this time or not, right? But on the very last day, we have just one condition. Do we have something to sell? Sell it, because there is no other day to make profit on. Okay. So what we will do, I will write a condition that we do not make those conditional changes for the last date. So I will write it like if I is not equal to, that means index is not equal to array of length minus 1. That means index has not reached the last element. Only till then we will make this comparison. And now I will take I plus 1, I plus 1 value. I plus 1 value would be like the next value, first value and second value. We'll compare on those 2 days values, and we'll keep iterating, right? So it would be something like ARR of I plus 1, right? So the next day value. Now comes the conditions. We have the value on the ith first day, second day, or ith day and I plus 1th day. So we'll make comparison on them. So we'll have to compare if I plus 1 value is greater than ith value, right? And along with that we'll have to see, is selling applicable? That means if selling is applicable is true, and the next day value is greater than today's value, then what should be our decision? We should not do anything, right? We should continue, right? We also, sorry, I missed one. We'd have to take a variable out of it in order to calculate the profit. It should be integer and profit equal to 0 initially, right? So what we will do, we will not add anything profit. So what this condition says, that today's value is less than that of tomorrow's value, and we have something to sell. So definitely we will sell tomorrow, because tomorrow value is going to increase, right? So we will continue. In this case we do not do anything. And next, in else if the same condition, I will write something like that, and selling is not applicable. That means purchase is applicable. So at this time, what would you? The next day, today's price is less than that of next date, and selling is not possible. That means you have some, selling is not possible. That means you don't have anything to sell. You need to buy, and next day prices are going to increase. So what you will do? I will buy today itself. I won't wait for the next day. And to buy from today, what I will have to do is I will have to pay that price from the profit, whatever profit I have, right? So I will like profit is equal to profit minus today's value. So this will calculate for me, or I can write like profit minus equal to ith value. Both are same, right? This should be together. Okay, so this indicates the same only. Now what would be the next condition? I'll write again, else if. Now let us reverse the, we'll have to reverse the condition. The first case was, the second day value is higher than that of today's date. But now we'll write condition like the second day value is less than that of today's case. Let us see, let us make decision based on that now. Okay. So what it says that on the next day, the value of share price would be less than that of today's, and we say that selling is applicable, the first condition. That means we have something to sell, and tomorrow the prices are going to decrease. So what we will do, we will sell out today only. So that means I would write like this price would add to profit plus equal to ith value. So ith value would increase at profit. I'm sorry, we are missing one more thing. It's like we would have to change this value as well. Earlier, when I'll move to this condition again, once again. So here what it was like, next day value was more than today's value and purchase was applicable, right? Purchase was applicable. So that means we bought it and now the selling should be applicable. So we'd have to change, since we have bought something, the selling should has to now change to true. Only then it will calculate, right? Similarly here what we did is like today's value is less than that of tomorrow and selling is applicable. So it's like we sold it and we got some profit. Now we would have to set the selling to false. Why? Because we have already sold it. We can only buy now, right? This way. Now, last else if condition would be on this, but the price change, right? We have taken out all the four possible combination. Now changing the symbol. It's like tomorrow the value is going to decrease and today the value is higher. And at this point, selling is not applicable, purchase is applicable, right? So it's like today value is more, tomorrow the share price is going to decrease and we have to buy something. Definitely we will wait and we won't buy at higher price today. We will wait for price to decrease tomorrow. So what we'll do is continue on this, right? So this becomes the entire logic, but we have to figure out, we'll have to wait for, we have to write condition on this as well, the last, right? Because we have taken uh, till I is not has not reached the final element of the array. That means the final day we have not reached. So we'll write an else condition here. Else if, okay, if we have wrote, so it is against this if, right? Let's show you, decrease the font a bit maybe, right? So this else is against this. If I is not equal to ARR length, that means if this else means that we have reached the final element. So we'll check just one condition. If selling is applicable, if this is true, then what we will do is we will write like profit plus equal to ARR of ARR dot length minus 1. So we'll add the final price to this and this would give us the profit. So we'll return the profit instead of 0 and let us see that does this work or not. Okay, I'll run this. That is our application. So it says max profit is 6, right? So this was required 6 only, right? Let us do a comparison on the other array. What I'll do, I'll maybe write I will write that and change the language. We'll have to declare an array integer, say price array 2, right? And what is the array that is given? We'll have to change it to curly braces, right? And I'll copy the statement to re-execute this method, this time with price to array. Let us see what it has to say. Max profit is 7, right? So here it should return 7, right? Let us take the third and final. I think we would have to make some changes because that array seems to be increasing the size of integer itself. We have return type integer, right? Let us see. I'll show you. I'm copy pasting this first, naming it as array 3, adding curly braces to it. Okay, now this time we'll pass this as array 3. Let us see. Let us see what profit it. The class got closed. I'll open that again. Let us see what profit it says. Oh, it is returning minus. Why? Because its size, it is way beyond the size of integer, because there are lot more digits over here. So what I will do, I will convert it to long first. Okay, and this profit to long also, so it would turn a long now. Not let us run it again, right? So it is running the profit 2999997 something. So this is what it says. It has to be something like this, but the function, it says that function should return this. The maximum possible income is this, which we are getting, but whose last 9 digits are this. So we need to get the last 9 digits only. This is pretty simple. What we have to do is we have to write like modulo. To return any last digit, you would have to write modulo 1, then number of digits that you want, that many times you would have to add zeros. 1 2 3 4 5 6 7 8 9. Okay, I'll save this. I'll run this. Okay, this is now returning the exact value for the first 6 7 and 999, right? So this was the solution to the problem that we had. I hope you would find this solution and explanation to this problem useful, and in terms of how to approach a problem, and how you can find out a human solution to the problem first and then try to solve this out. I hope this would add value to your knowledge. Thank you very much for watching this video. Stay tuned.